Alright, so I'm gonna try to make this easy for you by doing the work for you. Which in the short term can be good, in the long term it's probably not good. Okay, so the things we're talking about here, spiral similarity, similar switch, okay, and then we're gonna give you an example, and the example is in this Malaysian APMO qualifying exam, ST or something, question 3. Okay, so we're gonna explain the concept and give you an example. Okay, I think this is the format for a lot of like lectures and stuff. I don't really like this because I think you should try to solve the problem yourselves. But I mean, you can also you can't also do the same thing all the time. So if we have this once in a while, it's not too bad. Okay, so what is spiral similarity? Yeah, you guys are kind of annoying. What are you doing? Okay, so spiral similarity. Okay, so you can think of it. There's two things that make this thing. Okay, so what is it? It's a rotation and a dilation. Okay, you know what spiral similarity is? So it's like if you have a triangle like this. Okay, yeah, and the side lengths are like 1, 2, 3, right? And we can rotate about this point here. Yeah, and we get another triangle. Could be like, but it's bigger. Yeah. Okay, so then it's like 4,
5, and 6.
6. We just double the side lengths. Yeah. Actually, this doesn't even make a triangle. What the? We should probably make these side lengths longer.
1, 2, and 3.
This doesn't even make a triangle.
It's just a line.
So that is what we call a degenerate triangle.
Degenerate triangles.
Indeed.
Okay, how about we need 2, 3, and 4. How about that? 2, 3, 4.
I apologize.
What are you talking about? Yeah, why always ruin my videos? Okay, so you rotate it and you stretch it, yeah? Or shrink it, okay? That's what a spiral similarity is, okay? Yeah. I should also mention this is like smack in the middle of intermediate geometry, okay? So this is tested on the senior contest. And then okay. And what makes it special? Well, there's only so many geometric transformations, okay? There's basically like rotations, dilations, translations, and reflections, okay? So in some sense, if you have a direct similarity, okay, and there's a fixed point, it has to be a spiral similarity, okay? So it's basically, it's not just random transformations, like one of the only ones, okay? Okay, what's a similar switch? So every time you have a spiral similarity, okay, you get a similar switch. What is a similar switch? Do you guys know what a similar switch is? Oh, you were here on Saturday. You saw this. Okay, but you didn't see the example. Yeah. Okay. So this triangle, okay, is similar to this triangle.
Like a bow tie.
You see that?
Oh yeah.
Does that make sense? So whenever you have a spiral similarity, you also get a similar switch. So you can also think of it as a spiral similarity between the blue and the light blue and the red triangle.
Does it correspond?
Yeah. So in some sense, as long as you have 2 points and you rotate them, you get a triangle, right? So can you see why those two are similar if the other ones are similar? Can you? So because the other ones are similar, the angles are equal, right? So for example, this angle equals this angle from the similarity before. This angle equals this angle, and that angle equals that angle, right?
Yeah.
And so because of that, then the red angle, the angle here, the big angle is equal to the big blue angle because it's got the little angle the same and the middle part's common, right? Okay. And then
Wait, are you showing why that's true?
what?
Why those two are similar?
Yeah.
Can't you just argue that since when you select them, two sides you select will be in ratio with the other two sides, and the angles will be equal, and you have a common angle for each, so it's just
Yeah.
SAS.
I mean, I've only said the angles are equal. I haven't had a chance to say the sides are in ratio, but yeah, so basically the sides, because it was like we had 4 over 8 is equal to 3 over 6, right? That's what we started with, yeah? And what we want to end up with is we want 8 over 6 to equal 4 over 3, right? So that's with the blue and the red. But then you can get that by just cross multiplying. Okay, so you move the 8 up here, and you put the 3 down there, yeah? Okay. So that's a similar switch. Okay. So here's another interesting thing. So when you have a spiral similar switch diagram, okay? So when you have this, you can draw a circle, okay? You can draw a circle that passes through these 3 points, okay? Yes, of one of the triangles, yeah? And you can draw another circle that passes through the other 3 points, yeah? Of the other triangle, yeah? And the claim is that these circles intersect at this other intersection point here. Okay.
So just prove it's cyclic.
Yeah. So you can kind of see why that's true. So let's see. Yeah, so you can kind of see why that's true. Like for example, we know because of the similarity, this angle is equal to this angle, right? So that makes a bow tie, which makes that a circle. Yeah. And we know from the other similarity that this angle is equal to this angle, right? That makes a bow tie, and that makes a cycle. Yeah. And actually, anytime you have two intersecting circles like this, you always get a spiral similarity. Okay. So anytime you have two intersecting circles, they don't have to be equal in size, but you have like lines like this, okay? Then you always get a spiral similarity at the other point of intersection. So you always get a spiral similarity that sends this thing to this thing. Okay.
Just defined by 2.
Defined by 2 points. What do you mean?
If you choose to get the whole thing.
Yeah.
Which 2 points? What do you mean?
But if you choose another 2 points on the circle, you get the whole diagram.
Yeah. Yeah. Okay, good. And see, we can prove this because this angle is equal to this angle by bow tie, which is vertically opposite this angle and is equal to this angle, right? And then the other ones kind of are similar. So the other ones are like, so this angle here is equal to this angle here, right?
Yeah.
Bicyclic quads, and which is equal to this angle here. Yeah. Similarly, this angle here is equal to this angle here, which is equal to which is equal to, did I mark in the wrong angle? Yeah, I marked in the wrong angle, sorry. It's this angle here. And that's equal to this angle here. Okay. So so you always get that kind of spiral similarity when you have two intersecting circles. Okay. Okay. Yeah. So it's kind of crazy. Like all these things kind of fit together. Like it's not just a random transformation. It's pretty much one of the only ones. It's not a random two circles intersecting. This is pretty much the only way spiral similarity happens. Okay. So like if you had like a side of a triangle, and you know that it rotates to another side of the triangle by spiral similarity, right? Like how would you find the center of rotation? Okay. So what you could do is you could join these sides together, okay, and you'd make equal angles here, right? Okay. And see, it's unlikely for you to rotate it 180 degrees to make the equal angles. Okay, that's pretty unlikely, right? But what you can do is you can transport this angle along a circle. Yeah. So wherever this point goes, it could go somewhere here. It will make the same angle as it does over there, right? And you can do the same thing on the other side. Okay. And you can transport that angle, and then wherever they intersect is where the spiral of similarity starts, right? Because wherever it is, you need the angles to be equal. Okay. So I guess that doesn't quite explain why it has to actually be equal to the vertically opposite angles, but those are certainly one pair of equal angles. Okay, and then you get your intersecting circles again. Okay. So basically, whenever you have a spiral similarity, you get intersecting circles, and whenever you have intersecting circles, you have a spiral similarity. Okay. Whenever you have like a similarity, basically that's not a translation and it's direct. Direct basically just means it's not a reflection. Yeah. Like if it's clockwise, the other thing is also clockwise. It's not anti-clockwise. So then you basically get a spiral similarity. Okay, what about the example I promised you? Here's an example. So what was the question? So the way we solved this example, so this is by one of the, so I can't remember what his name was, but it was from the one of the solutions on the AOPS forum. Yeah.
Oh yeah.
Yeah. So the reason this example is so good is because it fully does the spiral similarity. Okay, but one thing you should note is a bit more advanced than we need in terms of spiral similarity. Okay. A lot of the time in like say senior contests, you just need to get the similar triangles and you can do some angle chasing and you're done, right? But this one really fully exploits transformations. So what is the question? So you have a triangle ABC, yeah? A, B, C, yeah? Then you draw the altitudes C and altitude at B, yeah? Okay. You get the midpoint, call it M, and you get the mid arc here. We don't give that a name, which is the whole point of the mid arc is to draw the angle bisector here. Okay. Okay, and then you draw the external angle bisector. Yeah. So the external angle bisector goes like this.
And what's B?
This is a triangle. What do you mean what's B?
I was like the line from B to there.
That's the altitude.
Oh, so that's not the X center.
No. We'll call this Y. And call this X. And this is obviously the orthocenter. Yes. It's hard competing for some people's attention. Okay, and let's call this. We'll call this one D. And this can be E. And this can be F. Okay. So the question says if you have a circle that goes through BHX, you know? Okay.
Yeah.
And another circle that goes through HCY, you know? Okay, how do I draw a circle through HCY? Yeah, I think that's not good. And let's call this Z, yeah? Yeah?
Circles the radical center unless the radical axis is parallel.
Okay.
What do you mean by radical center? I don't think Liam's burning himself out at least.
I'm citing my geometry facts.
Okay. So the question is asks you to prove that that angle I just drew is 9 degrees. So MZH is a right angle. Okay. That's what the question asks. Probably, yeah.
But does Liam know how to complex
Not today.
Next week?
Next week, I don't think we're interested in this problem next week. Maybe another problem. There'll be unlimited geometry problems. Don't worry.
You know what we should do? We should attempt a 40M problem in this class next week.
That's too hard.
What?
Why?
Okay.
Maybe 55M would be better.
There are 2 of those.
Oh, can we bash the problem 6 that I was bashing?
Well, we've already done that one. Hold on.
Oh.
Alright, so yeah. Okay, you guys ready? So we're gonna tell you, I mean, almost how to solve it. I mean, there's some steps at the end which I don't know if we will get into or not, but so there's some questions right now. It's like, how do you make use of the Z, right? Z seems to be a mystery point, yeah? Okay, and how do you make use of these angle bisector conditions? Like, what is really the definition of X and what is the definition of Y? Okay. Alright. So, how do you think we're going to make use of Z, by the way? And given all I've said, how do you think we're going to make use of Z? Well, this is how we're going to make use of Z. So, this is Z, right? This is H, yeah? That's B is here, okay? And that's Y, yeah? And X is there and C is there, yeah?
Similar switch?
Yeah, so we go to spiral similarity, yeah?
What are we trying to prove? Yeah.
Maybe you should stop looking
Oh,
at Quora and instead check your Discord.
yeah.
Even he knows you've got a thing in Quora.
It's like it's like
Because I was stalking him, of course I know. I know.
I feel like it'd be more bearable if he was one of the biological children and not one of the adopted kids, right?
Biological children of your parents?
He doesn't understand the joke. Okay.
Parents, one of them cheated. There's
None of my parents
What is
cheated.
wrong
What?
with you people? Stop.
No, he's talking.
His dad has black hair.
Can we try to? His dad does not have black hair.
What? That's because he's old.
It's because my dad's hair is like half silver. It used to be like completely black.
Really?
Yeah.
What happens
Focus on the
when a
problem.
person gets old?
Okay. You ready to do the solution to this?
What do you know about me and Quora?
You're just addicted.
Did Nathan tell you that?
Stop talking.
I don't think I stalk you.
I'm losing motivation.
I'm sorry, sir. You are my Lord and Savior.
What? Do you have the diagram that we had before?
Okay, so what's the diagram look like? So this means if so we have a triangle here, right? Yes? That's similar to this triangle here, right? Does that make sense?
Yeah.
It is a spiral similarity, okay?
Yeah.
Okay. So now the claim is, this is a pretty crazy claim, okay?
Wait. X is the intersection of what?
Of what?
X is the intersection of what?
X is the intersection of HC and the circle. Okay. So now this is a crazy claim, okay? This is the hard part of this. So if I take the points, so if I look at the altitude from B, right? Okay. And I take the midpoint, yeah? We call it MB. Yeah?
Yeah.
If I take the midpoint and look at MB, yeah?
Yeah.
Okay.
Oh yeah.
And I do the same for C, okay? And that's called MC. Yeah? Okay. Can you see that? Can you see that? MCMB. Yeah, he's past you.
Oh no!
Yeah, so there's nothing that gives you an advantage over him now. Alright, so MC and MB, the midpoints.
Yeah.
Can you see that they, if Z is 90-degree angle, then they would all lie on a circle, the same circle, MZ, HMC, MB.
MZ HM.
Hey, it's a smiley face.
MZ HM
Any positive emotion is unintentional.
MV. Wait, what all on? MZ HM MV.
MZ, HM,
MCMB.
yeah.
Guys.
Oh, what?
Can you see if the angle of Z is 90,
Yeah.
then MCMB is cyclic with MZH.
MC. Where's C? Where's M?
Oh my.
MC.
It's the two purple dots along with the light blue vertices. They would have to be cyclic if the problem was true. Or like the problem is equivalent to those things being cyclic.
Because they're 90. Oh, because the midpoint and the altitude.
Yeah.
It's parallel to that line.
Yes. See,
That's
I think Charlotte's building a pretty strong case for her Tuesday class entry. Liam, you're expelled from Tuesday.
Why can't you expel him from Monday?
What do you want me expelled from Monday class?
Okay, settle down. There'll be enough expulsions to go around.
What class did you ask me to be expelled from?
All of them.
No, but if you expel him from Monday class, I can't stalk him anymore on Monday.
What? Of course you can still stalk him. All you need is the internet.
It's like
Did you say Sunday
Alon's
class
the
or
opposite
Monday
of
class?
Stefan.
Mom,
It's like
Why do you want me
Stefan
expelled from
quit
Monday?
because of Liam. Alon joined because of Liam. It's like the opposite to Stefan. Okay.
This guy's like you
Listen.
to Anthony.
Listen up. Okay, so this is what Charlotte said. So if you join these two things together, right? Like if you join that, right? Because the midpoint's parallel to the base, right? And the base is 90 degrees, yeah? Because altitude. It's an altitude. Then that means this angle is 90 degrees, yeah? Right?
Yes, indeed.
And if that angle is 90 degrees and this angle is 90 degrees, then they make a circle, right? Because the opposite angles add up, the exterior angle is equal. Yeah.
Guys, it's a rectangle with 5 points.
Please. Okay, the same argument goes on this midpoint here, right? If you join this together,
Oh yeah.
that's 90 degrees because it's parallel with that base, yeah?
Very true, sir.
And so all of these have diameter mh, yeah?
Yeah.
Okay. So having said that,
What?
okay. So the midpoint is somewhere, like it's a little bit past h. It's like
This is a bit to Ryan soon.
it's a little bit past
What do you want
x.
me to do with the rocket?
So this is like
It's charisma.
It's like harassment, but with Riz.
what? What does that mean?
Oh, you know Selena? The
What?
one with the boyfriend? She kissed me last Wednesday.
What?
It was non-consensual.
Oh, that makes it worse.
That makes it worse
Thank you for clarifying.
than consensual. What is wrong with you people?
What? Kissing someone unconsensually is not worse than kissing someone consensually?
No, but I'm just saying, why do you have to say it?
Yeah.
This
Alright.
is harassment, that was harassment.
I'm not rizzing anyone up though. Why would I be rizzing
What's
You
harassment?
can't.
It's like Riz, but harassing.
I don't get it. Isn't Riz just meant to be like attractiveness?
You know, but
I
you're
have
rizzing
no
them
Riz.
up, but in a harassing way.
Oh, I
What?
see.
That doesn't make any sense.
That's normal then. I mean,
See how he recoiled?
Different from this kid.
Yeah. Okay. So the question is solved if MZH and the two purple points are cyclic. Yeah.
hopefully
Yes.
this doesn't have coaches.
Okay. Can you see that is equivalent to saying that MB is sent to MC under this spiral similarity?
MB.
Yeah,
to
'cause-
MC.
Why?
Because that's the point where you're rotating. Right?
So instead of doing Y, we're doing MB, and instead of doing C, we get to MC. You know?
Yeah, because they're both 90 degrees. And then you get a 90 degree.
MB is sent to MC. But where is it on the other diagram? Where's M on this other more
There
diagram?
is no M.
M's not related to this.
Oh. Then which M are you saying when MB is sent to MC?
What? I'm not talking about M.
And MC are not M.
Oh, they're sent to each other. Oh. That just means we have to prove the ratios are the same, right?
Yeah, but I'm asking why does knowing them being sent to each other prove the question?
Because it makes the 90-degree thing.
Well, we already know they're 290 degrees, right?
Yeah, and the 290 degrees makes the angle at Z 90 degrees.
How? Explain.
I don't know, it just seems like. Because, like, you're rotating about that point, right?
Yeah.
Yeah, so, MB and MC are like equivalents on the two triangles. So, because, you're rotating from one to the other, and you get 90 degrees.
Oh dear.
No.
Okay, so there's two ways to explain this, okay? So one of them is that basically whenever you get a spiral similarity, you get two intersecting circles. Okay? So and the other way to kind of explain it is by directly showing you the circle. So suppose that MB goes to MC, right?
Yeah.
Then this triangle here is spiral similar to this triangle here, right?
Yeah.
Yeah. Yes, that's like the definition of MB going to MC. Yeah. Okay. But now, if you notice now, this angle here, right, is equal to this angle here, right? Because they're part of the same pair. The corresponding angles on similar triangles.
Yeah.
Yeah. Which means that this yellow quad is a cyclic quad. Yeah.
Yeah.
Okay. Yes. So essentially, you get the same diagram, but with Y replaced by MB and C replaced by MC, right?
Yeah.
Okay.
Oh, it's like meta.
Yeah. Okay. And what that means, okay, in particular, that means that MB, MC, Z, H is cyclic. Yeah?
Yep. MB
Yeah, and there's another one, so all of them are cyclic.
Yeah.
Yeah. Yeah. So,
and we already know that the 90 degrees are cyclic, right?
Yeah, I said.
yeah, like we already know that um B, M, C, H is cyclic. Yeah? We already know that. Yes?
So all of them are cyclic.
So then all of them are cyclic, and because we know the angles are 90 degrees, then we know the angle of Z is 90 degrees. Okay?
Yeah.
Yeah. Okay, so then the question is, how do we prove that the point MB is sent to MC, right? Okay. But in some sense, the hard part of the problem is over, okay? So proving how MB sent to MC is actually easy now, because what you need is, because there already exists a spiral similarity, you just need MB to sit on the side BY in the right place relative to where MC sits on the side CH. Right? So if MB was the midpoint of BY, then obviously that will get sent to the midpoint of CH, right?
Yeah.
So we just need to show whatever the ratio is, it's the same on the other side. So we need to show the ratio YMB on MBH, okay, is equal to CMC on MCH, right? Oh, MCX. X. Wait, MCX. Oh, it should be X. Oops. Wait, did I draw the wrong? Hold on. No, I drew the wrong triangles here. It should be with X.
Is it? I can do
X.
Oh no.
Hey, look at this.
Yeah.
There's
Okay.
ink, and now there's ink.
Oh.
And the other triangle should be with X as well.
Yeah.
What?
I'm not harassing Ryan.
Why
Though.
you-
You know Ryan's good.
Destroying my tech stuff.
This is his.
Right, don't exert too much energy, okay? You're gonna need it for the exam tomorrow. Alright?
Yes, sir.
Yeah, Liam.
Especially on non even relevant things.
Yeah, good point.
You gotta learn to be a winner, okay?
It's not like you cheat on this exam.
And now we need to prove they're in the same ratio. Correct?
There's lots of people who are like tall, smart, blah 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 blah, but they're not winners, okay?
I don't think there are that many people.
Who? Like your uncle.
Like Anthony.
Anthony's not tall.
Anthony is not tall.
Anthony is a winner, okay?
Yeah, exactly.
Oh my god, he's white too.
Yeah, exactly.
Alright, listen up. We have. So if we just showed that ratio, then we're done, right? Okay. But it's actually kind of like now it should be pretty obvious how the angle bisectors come in, right?
Wait, how is MB and M?
You
See
use
the
the
fine-
angle
I should just say
bisector
X.
theorem.
I think I wrote the wrong thing here.
Calm down.
Yeah.
Oh, do you want to
exactly.
see a photo when he let me draw mustache on?
No, 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 no,
Yeah.
no, 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 no,
Let's find it.
Okay, we just.
no, no, no. You let me draw a mustache on you.
No, Liam, stop harassing him. Why not?
Wait, this is B.
I know Liam's tickle spots.
How did what?
Wait, what's your, what is it?
What are my tickle spots?
What is your tickle
I
spot?
have no clue.
Where you're ticklish.
Why do you want to tickle me?
Yeah, but where are
Okay, do you know what the angle bisector theorem is?
Yeah, it's that one is like that ratio to that ratio is the same as that ratio to that ratio.
Okay, but
Oh
what,
yeah,
what I
the
want
things are in the ratio.
no, what I want is the external angle bisector theorem. The external angle bisector.
It's like the angle doubling theorem.
That is 90.
So if this is like X, Y, B, C, yeah,
Yeah.
the external angle bisector theorem, okay, is, so if you call this U, and you call this V, yeah,
Drugs are not good for you.
so the internal angle bisector theorem, so this is alpha alpha, yeah, the internal angle bisector theorem says X over Y is equal to B over C, okay, but the external angle bisector theorem says V over U, okay,
Because X over Y.
oh, you know this?
No, I was guessing.
Yeah, it's the
like
same.
Slava.
Okay. When you get more advanced, you actually learn another way to remember this. This is because this forms a harmonic set. Okay. So essentially, the angle bisector divides the side length internally in the same ratio as the external angle bisector divides that side length externally.
Because
Okay.
it's like making another.
What?
First time Liam.
Yeah, Liam, finish the.
What do you want me to eat?
That.
Okay, and with this, it's enough to show the ratios. Okay. So I think it's probably more convenient to not write the letter MB anymore. So maybe instead of MB, we have BE. Okay. So we times this by 2. Okay. Times this by 2, and we get Y. What the?
Painkillers for weak people.
Yeah,
I don't take painkillers.
Oh, once I had to take 6 Panadol so I could fall asleep. That time I had a fever.
Hold on. How do we do this? Times it by 2. Wait, is this the right ratio? Okay, so times it by 2.
It's not steroid.
No.
So MBB times by 2 is BE. Yeah. And YMB times by 2 is, so it's YB minus MBB times by 2. Okay, so it's 2YB minus BE on BE, and we want to show that's equal to, and then we times both sides by 2 as well. So CMC times by 2 is just CF, you know?
CF, let's go.
And then MCX,
How do you go Baymax again?
MCX.
I said Baymax. This is not a Baymax.
MCX. Yeah, I don't know. So MCX maybe it could be CX minus MCC. CX minus MCC, so it's 2CX minus MCC, 2MCC, which is just CF again. Wait, do I have it upside down? I have this ratio upside down, don't I? Wait. So I want to show Y MB on MBB equals CMC on MCX. CF. YB on BE. YB on BE. That's exactly the angle, external angle bisector theorem thing. Okay, so what's YB on BE? It should be AE on AB. Yeah?
I want my money back.
AE on AB.
Do you want me to draw on you?
So 2AE on AB minus 1, yeah? And we want to show that's equal to CF.
Oh no.
That's a little bit weird. CX. Okay, CX.
Oh, sorry.
CX on XF.
No, that's.
Maybe we could write this as something like, so CF is CX plus XF, and the bottom is CX minus XF. Does that help?
Why is yours longer than mine?
So if you divide by XF, you get CX on XF plus 1 on CX on XF minus 1. And what's CX on XF? CX on XF is just, because the angle bisect is AC on AF. AC on AF.
What did you read it as? I think you read it correctly.
Okay.
Yeah.
This is not looking good for some reason. AC on AF
It's true though.
is
You can't say that to me now.
something related to, it's like
I'm not a Jew.
the one on sine of that angle. And AE on AB is, it's the same angle here. Yeah, something's gone wrong here.
That is
I think I've reversed the orientation.
oh, senior
I think this is a bit racist.
I'm a bit racist.
Shocking.
Guys, how hot would water have to be to like boil a person? Ask him for a friend.
Your concern.
Oh, I
Oh,
forgot. I did the
I did something
experiment
wrong. I
before.
think all the
Try boarding a
all the
person.
ingredients are right, and then that should get you to the answer.
Um,
Because these
a
things are
monkey.
equal. So it's meant to be two. These things are equal.
I tried boiling a monkey, but like,
Boarding a monkey.
That's a bit racist.
Oh wait, are they
sure, it
reciprocals
is
of
a
each
bit
other?
racist.
AE on AB is the same as AF on AC. So yeah, so this is 2x minus 1. And the other thing is 1 on x plus 1 on 1 on x minus 1.
Something shouldn't.
Surely that's not the same.
Look at this. So just look at this.
So it's x plus 1 on x minus
Your wrists are thinner than yours.
1
He
minus
weighs
x.
35 kilograms.
True. He's got no bones.
He's got no bone.
Like his bone structure is. Look at this.
Oh my god.
Wait. Look. Your bone structure, like you've got a lot more bone. He's got like his bones are so much smaller.
Well, because I'm not a Jew, that's why.
Wait, hold on. I think
You can't say that to me.
it might have got the MB.
Okay, then just pretend you didn't hear.
What is this?
I know you're asking me. You would know how to say that. You're
It's just drawing of Squidward.
Aren't you the one who wants to seem to eat long?
Nice drawing of Squidward that we all have.
So B goes to X and Y goes to C. I don't get it. What's wrong with this ratio here? So Y and B.
Accurate.
Y goes to C, MB goes to MC,
Accurate.
B goes to X. Two MCX.
What? What do I do with this?
If you look at 1, 2, 3, it's a stack of balls.
Why'd you have 3 balls?
Damn.
It's a stack of
More
bowling
balls than
balls.
you need.
It's a stack of bowling balls. A Jew always needs extra.
What are you talking about?
What's wrong with you people? Stop talking.
This is a video.
Can you just try to figure out what's gone wrong here?
I was to see and where.
Is this the ratio we're trying to show?
My MB. No. Wait.
Yeah,
Yeah.
it is. It is. That's right.
Yeah,
That's right, yeah?
Yeah.
Okay, that's right. Because we have expressions for like...
Bro, what? This kid has a photo of the Jew from
So YE on EB, or YE on YB, we know that.
among other things.
Feels like it's backwards or something.
It should be right.
Yeah?
The ratio is right. It's like the right orientation.
Yeah. Okay, well, how do we check it's true then? So I basically got something, but it doesn't. It must be wrong.
If you draw the altitude that you get them. Wait, that is the altitude.
Yeah. So I was thinking of timesing it by 2.
But so MC is the midpoint of CF.
Is it possible that MC? Wait, is it possible MC is on the right of X? Oh, that's not possible. No, I think it's B goes to X. B goes to X, and Y goes to C, MB goes to MC. It should be in between, right?
So are your hands clean now?
Yeah, I got rid of this one.
What about your one?
So I tried to keep.
Especially this one.
Oh, wait. I think I did a diagram in wait. I made some mistakes, but those mistakes don't actually save this. So wait, what if this was 1 on X? Does that?
If I tattoo it into your skin.
Yeah, don't tattoo it into my skin. No tattoos. Just kidding.
Oh, I'm getting closer though. A on AB. Alright, let's just try again, okay? So if we times... Okay, if you agree that's the ratio, okay? Do you agree that this is equivalent to timesing everything by 2, okay? So 2YMB on 2MBB equals 2CMC on 2MCX. Yeah?
No more.
Okay, and MBB, that's the midpoint, so that 2 of those is just BE, yeah? And 2CMC is just CF, okay? This is CF
Then what's the point of having 2 in both the ratio?
to get rid of the M's.
Yeah, but it's a ratio, so you can just get rid of the 2, right?
It's like this.
Yeah.
I have no trust in you.
It's
BE on CF.
Doesn't mean I have no trust in you.
BE on CF.
Those are the altitudes.
On the altitude, yeah. But they're also like
That should
BE
be like
is also the
80.
base of the triangle for the external angle bisector. Yeah.
B on CF should be like AB on AC, right?
Kind of, yeah.
Is it not?
But right, so what was it? So we have BE on and 2 MCX. What's MCX? So MCX, I could write that as CX
Nah.
or CX minus C. Jeez. CX minus CMB. So this is on CX minus CMC.
No.
And this thing here, YMB, is YB minus MBB.
This is when I had time. Wait, let's go. I have hair time now.
YB minus YB minus BMB. Yeah.
Yeah, how do you feel about folding?
He's coming.
You're not a likable person.
Who?
You.
Me?
Yeah.
This
I
is a
actually-
cult.
Okay, so this should be
Exactly what I'm talking about.
2yb
Is it like Switzerland accidentally invaded
minus
Lithuania once?
2be 2yb minus bf over be over be is supposed to equal cf over 2cx minus cf. Yeah, I don't know.
It should be right. Like, the ratio was right.
Yeah.
No, it's a cat boy. Oh, so yes, it could be.
Is it though? Is it?
Did you maybe reverse something?
Yeah, like would it be true if this was a reciprocal? It'd be true, right? Would it?
Yeah.
Oh,
But
what's
did
the
you maybe
CX?
reverse something that you shouldn't have there?
I reciprocated something.
Yeah. I know your address.
I know your address.
By stalking.
I know one of yours address.
Yeah, you know my address by stalking.
No,
Same.
your address was a mistake.
You tried to figure out yourself first and then failed.
I got like down to like 2 streets.
Yeah.
And 0 information. That's pretty
What
impressive.
do you mean by that?
Hmm.
He lives near Macquarie Meeting, I'm not gonna lie.
So what is it at the moment here? What's 2cx minus cf?
Close to Macquarie Meeting Station.
Okay, so what's cx over cf or cf over cx? So cf over cx. Cf
It's a rectangle.
over cx. That is
I think I can get high guys.
You calm down with that.
oh, that's why. So we don't want cx, it's cf.
What's CX and
Yeah, because that's the internal angle bisector, right? So we want cx and xf. Yeah. Yeah, so we should write cf. So we should replace cf by cx plus xf. Because it's an internal angle bisector. Okay. Okay, so this is actually equal to cx plus xf over
I don't want an emo TikToker. I turn you into an emo
Jewish
TikToker.
nose.
equals cx
Dean, are you sure you're not Jewish?
minus xf.
How sure?
Pretty sure.
Is your dad Jewish?
Don't think so.
How can you be sure though?
Is it Poland the most like Jewish?
Exactly.
Okay, so
Most Jewish population?
which ratio should we take? So xf over cx is equal to af
Poland is getting
over ac.
AF over AC. Yep.
Yeah, af over ac is equal to ae over ab.
No natural barriers from
Yeah.
equations.
Oh, wait. Yeah, ae over ab. And ae over ab. ae over ab is equal to ye over yb. So ye. Ah, okay. And we don't want be and yb. Wait, what do we want? BE. No, we do want BE and YB. So YB over YE, yeah, should equal to
What your reason for liking
Any of
Germany?
the other ones?
What the reason you like Germany?
YB
It's because of Poland.
It's good economy.
His
AB
boyfriend is Austrian.
Oh,
You guys
over
can
AE.
he looks like he's stupid.
You look more like you're stupid.
That over that.
I like Germany because it's strong economy, good military.
Alright, YB over
I've
A
got
YE equals AB over AE, yeah?
Its military is so good.
YB.
Germany is able to cope up the most.
Oh,
AE over. Oh yeah? Wait.
Do we know that or do we need to prove that?
that's like the angle bisector stuff.
Yeah.
AB over AE is equal to AC over AF. AC over AF.
So he's just naming former Soviet bloc countries and going, how do you feel about that? You aren't married some.
Oh wait, that's also the thing we have an issue with. We have YE instead of BE, yeah.
Not
So
really.
BE is actually
My grandmother's
YB
sister's daughter.
minus
Ah,
YE. Okay, I think we're gonna fix this now. So
Oh, she was gonna have
BE,
a kid, but the kid died.
oh really?
so BE is actually YB minus, yeah, I am recording. So it's YB minus YE, right? So the top becomes YB minus YE.
How do you feel about Switzerland's social status
Okay.
in the World War II?
YB plus YE. Okay, we're finally there. Look.
How do you feel about America?
Yeah.
It's pretty cool.
Aren't you you're Vietnamese, right?
Okay, and then if you divide that out, you get YB
People got mad at Oppenheimer, so they're making 9/11 jokes. Not
on
understanding
YE
that Americans love 9/11 jokes. Yeah, he
plus
loves American
1
jokes.
on YB on YE minus 1, yeah?
The Americans failed
And that
to invade
is
Vietnam.
CX
Unlike some
on XF
other countries,
plus
I'd
1,
say.
Like Germany.
CX on
Yeah,
XF
they helped them.
minus 1, okay? And then the point is YB on YE, we already said, so YB on YE is AB on AE, which is AC on AF, right?
Yeah.
And AC on AF is also CX on XF.
Yeah.
Okay?
And how's MA and MC defined?
Far out.
There's a...
Midpoints, right?
Yes!
It's like, what's my address?
10,000 straight, sir.
Oh. CX on FXF. So CX on XF is equal to YB on YE, right?
That's my address.
CX on XF is equal to YB on YE. So it's the same expression, they're equal. Okay?
Yeah.
Yeah.
Oh, what a waste of my time. Unless David and Ethan and
I was watching.
Lucas understood it.
I was watching.
And Ryan.
I watched.
I looked.
Well, I guess it doesn't matter if I watch.
I don't know why, but
Did you?
it's so much easier to understand things when you show them yourself. Like, sometimes it's harder to understand a proof than to come up with the proof yourself.
No, in this
Imagine
case it would have
how
been.
hard it is when
No.
it's the proof that you
No.
wrote.
You dumbass.
Oh my God.
It was supposed to be super easy to understand this. 'Cause
Oh,
I
this
literally
I
did
understand.
everything for you, okay?
This I understand. I understand this stuff.
You asked me what the freaking letters meant at the end.
No, but I understand it.
He was just like, oh, Michael's saying this is probably right. I'll just listen.
Oh,
No, I'm just
see, like it's sometimes better for kids to feel that like they're not loved, you know,
I don't
that they need to prove themselves to get a rightful place in this world, as opposed to being entitled to some.
Yeah, because then the love doesn't mean anything.
Yeah.
Really?
It's
I would
like,
prefer if
they're
my
like-
parents didn't love me. I'm thinking.
Are you?
What a
It's
stupid
annoying.
entitled idiot! Shut up!
It's annoying.
Oh,
Red and white.
okay.
what about your mother?
So does anyone understand? Does anyone have any questions about this? Can someone tell me roughly how this goes?
Basically, you like chase all the proportions, and because it's the midpoint, you can get different proportions. And then you get more proportions, and you end up knowing that one thing stands to the other because of the external and internal angle bisectors.
Yeah, so the word
Yeah.
angle bisectors have to come into it, or it's not part of it, right?
Yeah.
I said it, so why are you telling me that?
Wow.
Solid 6 on
Ah.
25.
How do you feel about German?
Oh, what's wrong with you?
I don't really mind about German. How do you feel about German people?
You people might be the first people to get demoted classes.
How would I get demoted? Would you put me in Saturday?
Oh, but I'm already in
Please
Saturday.
don't demote me, sir. I've got to, how about I perform well in senior contest and then you can't demote me?
What if I do better than Liam in senior contest?
How do I get to next week? I just get removed from the